Ever get that feeling like you want to just dive right into something, like you really want to understand a big idea without having to wade through tons of information?
Yeah, totally. I think we all kind of crave that, right? To get to the core of something quickly.
Absolutely. Yeah, and I think that's something we really try to do here, cut through the noise and get right to the heart of these really fascinating ideas.
For sure.
And today we're taking a deep dive into a concept that really taps into the power of the internet, the collective brain power of, well, countless people.
Yeah, it's like this idea that we can connect with all these minds out there, and together we can, well, achieve some pretty incredible things.
Yeah, exactly. So our topic today is crowdsourcing.
Crowdsourcing.
And we really want to explore how individuals, all working independently but connected through, the magic of the internet, contribute to problem solving, but on a massive scale.
Yeah, it's not just about having a lot of people involved, right? It's about how all their different perspectives and contributions kind of come together, creating something that's, well, way more powerful than any one person could do alone.
Exactly. And to guide us through this deep dive, we're going to be looking at a really interesting source. It's actually a transcript of a Code Curious video. And they do a great job of breaking down crowdsourcing using these really clear examples that, anyone can relate to.
Oh, I like Code Curious. Their stuff is always super accessible.
Yeah, they're great. And so our goal today is to kind of build on that foundation, really dig into the core concepts of crowdsourcing and, explore some of the really exciting possibilities, all while making sure you, our listeners, have those aha moments, without feeling like you're drowning in information.
Right. Keep it engaging and insightful. I like that.
So where do we start? Where should we jump into this whole world of crowdsourcing?
Well, a good place to begin might be to consider, the sheer amount of information that's now available to us online.
Yeah, it's overwhelming, right? I mean, there's so much data out there, just this incredible amount of information.
Exactly. And our source material, the Code Curious transcript, it really highlights the importance of public data sets in crowdsourcing, like how all that freely available information can be harnessed for good.
Yeah, that's a great point. These public data sets are a perfect example of how, widespread access to information can lead to, well, some pretty remarkable results. And the transcript specifically mentioned Kaggle, which I thought was really interesting.
Oh, Kaggle is awesome. It's more than just a place to find data. It's a whole community.
It is.
Yeah. They have courses on there and are covering things like data visualization, even TensorFlow tutorials, which, if you're interested in AI and machine learning, that's a big deal.
TensorFlow, yeah. That's huge in the AI world.
Right. But it goes even further. They have these competitions where, people can compete to solve real data science problems, and the rewards can be pretty sweet, like cash prizes even.
Wow, cash prizes. That definitely ups the ante.
Yeah, for sure. And then there are the notebooks. I think the transcript mentioned those too, which are like a space for collaborative coding, kind of like GitHub.
Oh, like GitHub, so data scientists can work together.
Exactly. They can share their code, their data sets, all their insights. And it's all about collaboration feedback,
Yeah.
helping each other create better, more innovative solutions.
Yeah, that makes a lot of sense. It's like a giant open source data science lab. Everyone's working together, pushing the boundaries.
Yes. Oh, and then of course you have Google Public Datasets, another amazing resource.
Oh, right. Google has to be in the mix.
Of course. And they're pretty generous with it, actually. You get the first terabyte of data download free.
Free. That's amazing. So anyone can just jump in and start exploring.
Pretty much. And it integrates with BigQuery, which is Google's data analysis service, the one that uses SQL.
Okay, SQL. So for people who don't know, what's the significance of that?
Well, SQL is kind of a foundational language for anyone who works with data. Like if you're a data scientist, you need to know SQL. And Google Public Datasets, it gives people a way to get hands-on experience with SQL. Like they're actually using the tools that professionals use.
So it's not just about the raw data. It's about providing the tools and the environment to actually learn and grow. That's pretty cool.
Yeah, I think so too.
And then the transcript also mentioned government data, both at the federal and local levels, which, that's a more traditional concept of data sharing, right?
Right, exactly. Governments have been collecting and sharing data for a long time. But I think what's interesting is that nowadays there's a much greater emphasis on transparency.
Oh, for sure. Like making that data accessible to the public.
Yeah. Governments at all levels, from national to local, they're making tons of data public.
Yeah.
Covering everything from agriculture to energy, water management, even public health.
Wow, so much data. And what's the purpose of all that transparency?
Well, I think a big part of it is accountability. It allows researchers, journalists, even everyday citizens to kind of look under the hood, see what's going on, identify potential problems, hold those in power accountable.
Yeah, that makes sense. Like, hey, this is what we're doing. Take a look.
Exactly. And it's not just about accountability. This data can be incredibly valuable for data scientists who are trying to understand their communities and, come up with solutions to local problems.
Okay, so we've talked about access to information, public data sets. What's the next key element of crowdsourcing? What else do we need to consider?
Well, I think the next logical step is to consider distributed computing.
Distributed computing. Okay, so break that down for me. What exactly does that mean?
So basically, it's the idea that people can voluntarily donate their unused processing power to help with computationally intensive tasks. Those tasks that require a ton of computing power.
Oh, okay. So like my computer's sitting there not doing much, and it could be contributing to something bigger.
Exactly. It's like, hey, I'm not using all my brain power right now. Why not put it to good use?
I love that. And the transcript highlighted folding at home as a prime example.
Yeah.
I actually remember hearing about folding at home years ago. It was even on PlayStation 3 at one point.
Oh, yeah, that's right. It started at Stanford University and it really caught on. But yeah, you're right. It was even on PS3. I remember that.
Gamers contributing to science. It's pretty awesome.
Yeah, it was a pretty cool idea. And the whole goal of folding at home, it's to understand protein folding. How proteins fold into these specific 3D shapes.
Okay, protein folding.
Yeah.
So remind me, why is that important? Why do we care how proteins fold?
Well, proteins are basically the building blocks of life. They do all sorts of things in our bodies, but the way they fold, their 3D structure, it's really important for their function. Like, if a protein misfolds, it can lead to all sorts of problems.
Stops like
diseases, serious diseases like cancer, Alzheimer's, Huntington's. These are all linked to misfolded proteins.
So scientists are trying to figure out why those misfolds happen.
Exactly. And that's where folding at home comes in. It's all about simulating protein folding, but these simulations are really complex. They require massive amounts of computing power. So what they do is they break down the simulations into smaller chunks and distribute them to all these volunteer computers around the world.
So it's like a giant decentralized supercomputer working on this one problem.
Yeah, that's a great way to put it. And each computer, it processes its little chunk of the simulation and sends the results back to Stanford. And together, they're able to make these calculations that would be impossible for any one research team to do on their own.
That's incredible. Like the power of collaboration, right? Bringing all these resources together to tackle a really challenging problem.
Yeah, exactly. And speaking of advancements, the transcript also mentioned AlphaFold, which is a more recent development.
AlphaFold. Okay, fill me in. What's that all about?
So AlphaFold, it was developed by Google's DeepMind, and it's basically, well, it's a huge breakthrough in the field of protein folding. Like, in many cases, it's actually solved the problem.
Solve the problem? What do you mean?
Well, it means that given a protein's amino acid sequence, AlphaFold can predict its 3D structure with incredible accuracy, which is huge. Like, it has massive implications for drug discovery, understanding diseases,
So it's like we've unlocked a key piece of the puzzle when it comes to understanding these fundamental biological processes.
Yeah, I think that's a fair assessment.
And it's all thanks to, well, the incredible power of computation. Now, folding at home wasn't the only distributed computing project mentioned in the transcript, right?
No.
There was also something called BOINC.
Yes, BOINC. That stands for Berkeley Open Infrastructure for Network Computing, and it's based at UC Berkeley, as you might have guessed. It's similar to folding at home, but it has a much broader scope.
Broader scope, so it's not just focused on protein folding.
Right. BOINC supports a wide range of projects, everything from mathematics and astrophysics to climate research and, get this, Minecraft at home.
Wait, Minecraft at home? That sounds surprisingly specific. What's that all about?
Well, from what I understand, it's about using distributed computing to generate Minecraft worlds. Like, they distribute these seeds, which are basically starting codes, to all these volunteer computers. And the computers generate the world based on that seed and then send back information about what they created.
So it's like crowdsourcing Minecraft world generation.
Pretty much. It's a fun example of how distributed computing can be applied to, well, just about anything that requires a lot of processing power, even if it's not directly related to, solving some big scientific mystery.
It really highlights the versatility of the concept. So we've looked at data, computing power. The transcript then introduced this idea of citizen science. which feels like a natural progression from these concepts.
Definitely. Citizen science is all about breaking down the barriers between, professional scientists and the general public.
Okay, break that down for me. What does that actually look like?
So it basically means that anyone, regardless of their scientific background, can contribute to real scientific research. It's about leveraging the power of the crowd to collect data, make observations, all sorts of things.
Well, like the folding at home example,
Yeah.
where people are donating their computing power.
Yeah, exactly. That's one form of citizen science. But it can also be things like, bird counts or tracking weather patterns, people using their smartphones or other devices to contribute to larger research projects.
So it's like empowering people to become citizen scientists, contributing to our understanding of the world around us.
Exactly. And the transcript really emphasized how citizen science has had a huge impact on various scientific fields. Like, it's enabled data collection on a scale that would be impossible for any one research team to achieve.
It's amazing to think about, like all these people all over the world contributing to science. And it's all made possible by technology, right? Like the internet and smartphones and all these tools that connect us.
Totally. It's about amplifying human capabilities through collaboration. It's not just about the machines, it's about the people behind the machines.
I love that. Okay, so we've talked about data, computing power, citizen science. What about the actual outcomes of crowdsourcing? Like, what are some real-world examples of innovations that have been made possible by crowdsourcing?
That's a great question. And the transcript provided some really cool examples, starting with something I think most of us use every day, Spotify.
Oh, yeah, Spotify. I use it all the time. And the collaborative playlist, that's like a really obvious example of crowdsourcing, right?
Exactly. Like, everyone at a party can add their favorite songs. It's a simple but effective way for a group of people to create something together. But the transcript also pointed out Spotify's music discovery algorithm, which is a more sophisticated application of crowdsourcing.
Okay, the algorithm. How does that work? Like, how is it crowdsourced?
Well, think about it this way. Spotify learns what music you might enjoy based not just on your own listening habits, but on the listening habits of millions of other users.
So it's like analyzing everyone's listening patterns.
Exactly. And by analyzing all that data, Spotify can identify these correlations, like, oh, people who listen to this artist also tend to listen to this other artist, and that's how they make those recommendations.
Wow, that's really cool. It's like tapping into this massive collective musical consciousness. And the transcript mentioned something about metadata writing. That's a newer feature, right?
Yeah, it's relatively new, and it's basically a way for users to contribute to the information about songs. Adding descriptions, tags, things like that.
So it's like crowdsourcing the descriptions of songs.
Exactly. And what's really interesting is that they have this community approval mechanism. So it's not just anyone can add anything. Like, other users have to vet the contributions.
Well, that's a good idea. Keeps things accurate.
Right. And it actually reminded me a lot of Wikipedia, which is, of course, another hugely successful crowdsourcing project.
Ah, yes, Wikipedia. The encyclopedia that anyone can edit.
Exactly. And, it's not always perfect, but it's an incredible resource. And it's a testament to what a global community can achieve when they work together.
It really is. Okay, so from music to information, crowdsourcing is reshaping how we create and consume content. The transcript then shifted to the world of funding with crowdfunding platforms.
Yeah, crowdfunding. It's such a game changer.
And Kickstarter, that was the first one that came to mind for me too. It's like you have this idea and you pitch it to a massive online audience. And if enough people believe in it, they can contribute money to help make it happen.
Exactly. The transcript made a great comparison to Shark Tank. But instead of a few wealthy investors, you have the potential to reach millions of people.
Yeah, it's like democratizing access to funding.
Yeah.
And Indiegogo was mentioned as well.
Right, Indiegogo. And while it's often associated with, nonprofits and charitable causes, both platforms, along with many others, support all sorts of projects.
It's amazing how many crowdfunding platforms are out there. And it really speaks to the power of this model, right? Connecting people who need funding with people who are passionate about supporting new ideas.
Totally. It's about breaking down those traditional barriers and opening up new possibilities. And then the last example in the transcript was blockchain technology.
Oh, blockchain. It's a word that gets thrown around a lot these days.
For sure. And it's often associated with cryptocurrency, but the transcript actually highlighted a really interesting application: securing concert tickets.
Concert tickets. Okay, explain that to me. How does blockchain secure tickets?
Well, the basic idea is that with blockchain, the data isn't stored in one central location. It's distributed across a network of computers.
Okay, so it's decentralized.
Exactly. And each new piece of information, or block, it's linked to the previous one using cryptography. So it's like this chain of blocks all linked together securely.
So it's very difficult to tamper with.
Exactly. Because it's not like there's one central point of failure. Like, to hack the system, you'd have to hack all these computers in the network. And each computer is constantly verifying the authenticity of the information.
So it's like a collective effort to maintain the integrity of the data. That's really clever.
Yeah, I think it's a pretty elegant solution. And it shows how blockchain can be used for so much more than just cryptocurrency.
Okay, so we've covered a lot of ground here. From data sets to distributed computing, citizen science, all these real-world innovations. What are the core principles, the key takeaways that really define crowdsourcing?
Well, the transcript put it really clearly. Crowdsourcing is about obtaining input or information from a large number of people via the internet. But it's more than just asking a crowd for help.
It's about
creating new models for collaboration, connecting businesses, social causes, individuals with the resources they need to achieve their goals.
whether it's information, funding, processing power, whatever it is.
Exactly. And it's about harnessing the collective intelligence of the crowd to solve problems, to create something new, to push the boundaries of what's possible.
It's incredible to think about, right? Like all this potential out there. And it all comes back to that initial idea of, wanting to understand something complex quickly, to dive right in and explore it. And I think we've done that today with crowdsourcing.
I think so too. It's been a great deep dive.
And it really brings us full circle to our learning objective, which was to understand how people participate in these massive problem-solving processes, all thanks to, well, the incredible reach and power of computers and the internet.
Absolutely. And I think what really resonated with me from the Code Curious video was the speaker's point about how even though the internet connects us to this vast global community, we often tend to stay within our own little bubbles,
Yeah, we stick to our own little corners of the internet.
Right. But the beauty of these online tools, the very idea of crowdsourcing, is that it gives us a way to break out of those bubbles, to reach out and connect with people from all over the world, to contribute to something bigger than ourselves.
Yeah, it's like a reminder that we're all part of something much larger.
Exactly.
So as you, our listener, think about everything we've discussed today, the wealth of data out there, the power of distributed computing, the impact of citizen science, the possibilities of crowdfunding, all of it, consider this. What kind of problems do you feel drawn to contribute to, even in a small way?
It's a good question to ask yourself.
Because, with all these amazing tools and platforms at our fingertips, there's so many ways to get involved to make a difference. Maybe it's contributing to a data science project, or donating your spare computing power, or supporting a crowdfunding campaign.
Or even just sharing your knowledge and expertise with others. Answering questions, offering advice, every little bit helps.
Exactly. It's about finding that thing that sparks your curiosity, that ignites your passion, and then, taking that first step, reaching out, connecting with others who share your interests.
And who knows, you might just surprise yourself with what you can achieve.
Absolutely. And that's the beauty of crowdsourcing. It's about harnessing the collective power of the crowd, bringing together diverse perspectives and talents to create something truly remarkable.
Something that none of us could have accomplished alone.
And that's something worth thinking about, right? The power of collaboration, the potential for positive change. It's all out there, waiting to be discovered.
So go explore, dive in. You might just find your next big adventure waiting for you in the world of crowdsourcing.
Absolutely. And that's our deep dive for today. Thanks for joining us.
Until next time.